earlier in the semester, we talked about profit function and taking the derivative to find what we call the marginal profit. Now, in a typical profit function, what it gives us is the profit that we would make for selling X items or whatever the unit would be that we care about. And the reason we might want to differentiate to find a marginal profit is because it would give us the rate at which the profit is increasing or decreasing at a particular point in time, or in this case, based on how many units we sell. And say we wanted to find the maximum profit, we could find the critical value, take the derivative, set it equal to 0 to solve where is the maximum point. And we call it a marginal profit function because it gives us basically the amount of profit we get for producing one more item at a certain sales point. So say like we're looking at p prime of 10 or p prime of 100. P prime of 10 would tell us, well, what's the amount of profit we'd get? What's the rate of profit increasing at? So if we sold one more, it would be exactly equal to that increase in profit. Or if we're P prime of 100 would tell us, well, how much more profit would we make for selling one more at the point of 100. And we called this marginalizing back in chapter 3. But all that being said, a lot of times companies actually know their marginal profit function. They don't actually know their original profit, because they can say, well, today we have sold this many items and we know approximately the rate or the average amount of profitability for each item. And the question would be, what would be a proper mathematical function which models that marginal profit? Or essentially, we could look at this as if we take the antiderivative of the marginal profit function, the antiderivative of a derivative would cancel itself out, or return back to normal, right? Because the derivative of p is p prime, the antiderivative of p prime would take us right back to p, technically plus c. But anyways, let's look at this particular example, number 7. It says United Airlines determined that the marginal profit for selling X seats on their jet in hundreds of dollars is given by p prime of x is equal to 90 times the square root of x minus 580. Essentially, we have a function which models the rate of change of their profit function. And we could always start by graphing this function to get a better understanding of what it looks like and what it means. So let's go ahead and do that as the packet says. So we'll type in our function 90 times the square root of x minus 580 into our graphing calculator. And it says graph it on the window 0 to 200 by negative 600 to 800. So if I go into my window, I can change all these things to be, well, basically starting at x equal to 0 and going to 200. And all that means is between 0 to 200 seats. Like, we'll just assume that this is a 200 seat jet, but that might be more than actually makes sense depending on your average airplane. And then it says y min going from negative 600 to 800. And this is the range of our profit rate, basically the change in profit over that period of time. And we'll go ahead and hit graph. And what we get is, since it is a square root function with an intercept, it starts negative and it moves to positive. And let's go ahead and sketch out what we've got here. Something kind of like this is the shape that we have. Let me do that a little bit better. Going to keep on increasing over time. And we have a particular point which appears to be the x-intercept of p prime. And this is on the interval to 0 to 200. And we're going from negative 600 to 800 at the top. And anyways, let's answer some of the questions now, and we'll use the graph to analyze this further as we progress. But it says, first of all, find the total profit if the airline sold 50 seats. So essentially, they know the pattern of their marginal profit function for every individual seat sold. And let's say we wanted to know what is the actual profit, because it's not the same thing. But, again, we could figure out, well, what is our antiderivative function profit by taking the general antiderivative. Or I could kind of imagine this using area. Another thing I might be curious about is where is the x-intercept of p prime? We weren't actually asked that, but we could always calculate an intercept by doing second calculate 0, which will tell us the 0 value of any function, which is just a synonym for x-intercept. And after, you have to kind of know how to get the calculator to do it, but it appears as though our x-intercept is approximately positive 41.53. But anyways, if we wanted to find the total profit having sold 50 seats, well, we'd want to go all the way up till 50. Basically, we'd need to figure out what is the area underneath the curve in this particular interval of time. And in the last couple videos, I talked a little bit about, remember how area underneath the curve will actually come out as negative. So if I was to take a definite integral of this function, if I want to know how much area is in that, I need to take the definite integral from 0 to the x-intercept. And that should end up being negative. And then area which is above the curve should come out as positive. And what I'd expect by looking at this graph is I'm going to be losing profit. I'd expect to have a negative overall profit. And remember that the area under the curve is correspondent to the antiderivative function, but that is essentially what our profit is. So we can kind of visualize this amount is going to correspond to our profit, since the graph is of a marginal profit function. Or again, if I wanted to find the answer here, I just need to integrate from 0 to 50 of p prime, which is 90 times the square root of x minus 580 with respect to x. So this should give me the area under the curve again, which will give me my profit function. And if I want to find it in that specific interval, I would just want to do it from 0 to 50. And as I showed you last time, we could do this with a calculator, but let's, again, on an exam, I always want you to do it by hand. And you can use your calculator to check always. And also remember, for finding an antiderivative, it would be nice to rewrite the square root of x as x to the 1/2. Because remember, when we're finding antiderivatives, useful to use the reverse power rule. And so again, first step to solving a definite integral is solve your antiderivative. So notice that also I have 90, and I could factor out some stuff here because I have a common factor of 10, but we'll just leave it for the sake of ease. But basically, x to the 1/2, 90 would, again, the coefficient won't affect the antiderivative. X to the 1/2 would become 3/2, because I always need to add 1 when I'm applying the reverse power rule. Actually, let me change the way I'm writing this just a little bit. 90x to the 3/2. And then I need to drop the reciprocal. So I'm going to drop 2/3. So basically, the 2/3 will multiply by 90. And then the antiderivative of 580 is just 580x. And remember, we don't need plus c because this integral is a definite integral. And then I need to evaluate this from 0 to 50. So we plug in 50 first. Also notice that 0 will give me 0 here, so I could just skip this because it will be whatever 50 is upon plugging in minus 0. So we're going to have, 2/3 times 90 is just 60. And x to the 3/2 is just the square root of x cubed. And so if I were to plug in, 50 in there, that would be, the square root of x cubed. And we don't usually write the index of 2 when it's a square root, but 3/2 just would mean that. And then this would be minus 580 times x. So plugging in 50, and then again, I would have minus 0 there as well, but don't really need to bother with that. And let's go ahead and use our calculator to figure out what this would give us. So I'd have 60, and I could always just leave it as times 50 to the 3/2 power. I don't have to change it back to a root because the calculator is perfectly capable of dealing with fractional exponents. Minus 580 times 50. And this should give me my total profit. And I forgot the minus sign. I used plus on accident. And this would give me my total profit for having sold 50 seats. So negative $7,786.80 if I round to the nearest cent. And basically, we lost a whole heck of a lot of money. We don't like that at all. So even though the marginal profit decreases the more and more I sell, meaning that the rate of profitability is getting lower and lower, we're actually still, we obviously need to sell as many seats as we can to make as much profit as we can. And then if I wanted to find the profit of selling 200 seats, same deal. It would just be integrating all the way to the end, and it would add in all that additional point of area. And another thing about integrals is whether whether or not it's above or below, it will always give you the area that's bounded by the curve and the x-axis. So if your curve is beneath the x-axis, it will give you the portion of area above, and if your curve is above the x-axis, always give you the portion below. So you can just straight integrate on a boundary. You don't have to split it up into groups. You can if you'd like to, but since the point at which it passes 0 is a little bit odd here, we don't really need to worry about that. But anyways, the profit for selling 200 seats would just be the same problem, but integrating all the way to x is equal to 200. And again, we already know the antiderivative function, so all we have to do is plug it in. So again, this would be 60x to the 3/2 minus 580x evaluated from 0 to 200. And if I were to plug in 200 instead, I just need to replace that in my formula, in my antiderivative function. So 200 is now in there. That looks good. And that would be approximately $53,000, $705.63 if I round to the nearest cent. So a lot more profit, obviously, because we sold, assuming that was the capacity of the plane, all the seats. And naturally, finding the generic antiderivative or finding the generic profit function in the same sort of sense would be, well, P of x would be equal to the function just itself, 60x to the 3/2 minus 580x. And again, the question is, do I need plus c or not? But because again, what if I sold 0 seats? Notice how this function would be a little strange, because if I did sell 0 seats, it would imply that the profit is 0, which doesn't really make sense. But thinking about it on a definite basis, you could think about this as, well, it's starting with 1. If I sold 1 seat, this would be a highly negative profit function. And so that's sort of where it begins, where I should be using this function for. And then the last question says, is find the break-even point. Like, how many seats must I sell in order to become profitable? And notice it's not the same as the x-intercept of the derivative function, because this x-intercept is just the point where the rate goes from negative to positive in terms of its derivative. Remember, a derivative being negative just means it's a downward slope, and derivative being positive means upward slope. And if we were to look at the antiderivative function, 60x to the 3/2 minus 580x, and you were to take a peek at what this would look like, well, this is on a much larger interval. Let's say we went from negative 10,000 to 50,000, because this should actually be our raw profit numbers. And actually, I need to increase let's say from negative 20,000, because we're looking at the margins of our actual profit now. Notice that actually it starts by going down and comes back up, because remember, a derivative function tells you whether it's increasing or decreasing. When it's negative, the function is decreasing up until the minimum. And remember that when the derivative is 0, this is what we call the critical value. This would give us, in this case, actually the minimum, the absolute worst point for our profitability. Because it's like, well, if you think about the net profit, the further and further I go, we have a negative number, which is worse and worse and worse, up until a point when it becomes positive. So the break-even point is actually the point where the area would balance itself out between positive and negative. And so it would be like where, and remember, by definition, break-even point is when the profit is 0. It's when, and since the profit is given by the area, that's why this is making sense here. But essentially, all we need to do is take this function and set it equal to 0 and solve algebraically. So 0 is equal to 60x to the 3/2 minus 580x. And actually, we could factor out 10, and 58 is not divisible by 6, but if we were to factor out, notice there is a common factor of x as well. If we were to factor out 10x from this, we'd be left with 6 x to the 1/2 minus 58, and I factored out x from that as well. And actually, we could also factor out 2 from this. This would be 20x times 3x to the 1/2 minus 50 divided by 2 would be 29. And we would get basically 2 break-even points. Well, first of all, 0. Again, that doesn't really make sense. But another point at which the profit was 0 was based on this factor right here. So if I took that 3 times the square root of x minus 29 and set it equal to 0, I could figure out approximately where x would break even, which based on my graph of the profitability function, I would expect it to be somewhere about here. Or looking at it, I can see it's right exactly here because this graph is my actual profit function. But this would be, well, 3 root x is equal to 29. So square root of x should be equal to 29 over 3. And then squaring both sides, I would have x is equal to 29 over 3 squared. And so that would give me approximately 93 seats on this plane for the break-even point, 93.44 for repeating exactly. Or with break-even points, you always want to round those up, because if you sold less than the break-even point, you'd still be in the negative profit line. So really, we want to sell 94 seats to break even in this particular case. Anyways, that will wrap up this example. In the next video, I'll talk a little bit more about some properties of definite integrals, and that will wrap up videos for this week.